Welcome to Science Wars, Chemistry, Bio, Physics, Medical, which field is best? I understand the force and energy, quantum mechanics and relativity. My field is pure and they rely on.
Hello, in this video we're going to quickly go over the Vostok ice core data and analyze it and answer some questions about it. So first off, what is the Vostok ice core? So this is up in above Russia, and we have this ice flow. It is literally an ice field, and they have dug down, the Vostok station has dug down through the ice core, right? And there is data in that ice on the levels of methane and carbon dioxide from early in the Earth's atmosphere when the first layers of this ice were laid down, and each piece of little ice cube had maybe a little sample of atmosphere in it, so we can use those samples of ancient atmosphere to see how the methane and carbon dioxide levels have changed over time, where the more recent time would be close to the surface and further down would be further away. So we have the data and we are going to analyze that, and I made a PowerPoint to do that. Here is what the document looks like, and the PowerPoint will take us through each of these questions and analyze the data that we have from this. So let's go bring up the PowerPoint and let's get started.
All right, so here's the PowerPoint and let's get started. Climate change, Vostok ice core data. So with these, each of the questions should be addressed as we go through, and the questions will be pulled up along with the data. So here's what the data looks like, and then the questions will come up like this, and we should be able to answer them. Okay, look for patterns in the carbon dioxide and methane gas data. Describe what happens to the carbon dioxide and methane over time. So we're looking for patterns in carbon dioxide. So let's look at this graph. We have our carbon dioxide right here, so that's our red line, and it goes up and down and up and down. On the bottom we have where this comes from, so thousands of years to the present. So the present is here, and then thousands of years back is here. So this is 400,000 years ago. And then we have methane over here, and that's in parts per billion, and this is in parts per million. So very much less methane. And then we have global temperatures here. It's temperature difference change. So where 0 is no difference, and so an increase of 2 degrees over the normal, and then decreases of all the way down to -8 degrees below the normal. All right, so describe what happens to carbon dioxide and methane over time. So over time, what are these gases doing? All right, so you just describe that. What are the gases doing over time? Let's move on to our next question. So questions 2, 3, and 4 all deal with relationships between the gases. So we can talk about that as a correlation, where a correlation is, so there's our question. The correlation is when you have a set of data, if that set of data is in a direction, there's a point that you can actually a straight line you can move through it, then we say it has a positive correlation. If those points kind of lead in a negative direction or downwards, that's a negative correlation. Or if the points are just scattered everywhere, there's no correlation. So correlation is some kind of relationship between a positive or negative degree. So does methane and carbon dioxide data have a positive relationship or a negative relationship? So carbon dioxide, it's going down here, methane, it's going down. So they both have the same relationship. So here they have a negative relationship, and then they have a positive relationship, and a negative, and a positive. So the relationship seems to be the same over time. As one goes up, the other one goes up, and as one goes down, the other one goes down. So this could mean that one causes the other, or it could have no relationship on cause, but they both are doing the same thing at roughly the same time, which is interesting. Describe the patterns in CO2 and temperature data. So we have our CO2 data here, our temperature data here, and again, you can see what the pattern is saying. for this relationship. So it looks like as this goes down, this goes down. So it doesn't necessarily mean that one causes the other, but there is definitely a relationship between carbon dioxide and temperature, and that is for sure. So one goes down, and one goes up, one goes up. So again, going over positive and negative. So yes, there is definitely a positive and a negative relationship between both of these, or we can just say that there is definitely a relationship between the two because they both go up and down. Now, if you look at it over time, you can also see this, where if we look at the temperature data from NASA, if you look at the Mauna Loa CO2 levels, which we've actually recorded and looked at in assignment 6, 8, and 7, you can see that the CO2 data and is going up and up and up and up since the 1950s, more carbon dioxide in the environment. And as the carbon dioxide is going up, the temperature is going up also. Now, it doesn't always fit, like right here it doesn't fit, and that was in the 1940s. But it does look like there's something going on, because as the CO2 goes up, the temperatures are going up. So carbon dioxide and methane gases are greenhouse gases. They trap thermal radiation in the Earth's atmosphere, so it can escape into space. So it cannot escape into space. Please infer the relationship between the greenhouse gases and temperature. So again, we are just inferring this. It sure does look like that as these go down and up and down and up, that there is a definite relationship between the two greenhouse gases and temperature over time. Present-day levels, values of carbon dioxide and methane gas are found at the top of the chart. How does the concentration of methane and carbon dioxide from 320,000 years ago compare with the current concentrations today? So 320,000 years ago is roughly right about here. So that's the highest levels that we had of carbon dioxide. Not quite the highest levels for methane. Methane, the highest levels were around about 140,000 years ago. But here's the present day levels. Here's CO2 way up here. Present day levels are way above where they were even at the highest. And here's the methane levels. And here's the methane highest level. So we are way, way above methane. So methane has increased dramatically, way above what CO2 has on the scale. Right, so you can go ahead and talk about that in that question. Again, the methane level is much higher than they were, 1,700 parts per billion versus it only being roughly around 680 parts per billion, and then the carbon dioxide levels were at 300, and now they're at 365. So you can see this over time. Again, here's our temperature and CO2 data. So temperature being in red, CO2, and you can see that they track pretty. Their relationship seems to be very much the same. And then here's our CO2 data today in 2000. Well, not today, 2007 data, but you can see that it was going up and up and up and up and up and up. This was at the 300, and we're at 365. So there's a very nice relationship between these two, if nothing else, and that's where the data seems to be pointing. So we can see the same thing with the methane. If we look at it closely, here's the methane levels, and you can see that the methane levels today are much higher than they were, as we said, 1,700, very close to that. All right, so methane levels have gone up drastically in the last 100 years. So present-day carbon dioxide and methane gases are found at the top. How does the concentration of methane and carbon dioxide with current concentration? So you should be able to answer that now. So were the concentrations of methane and carbon dioxide ever higher than they are today? And so we already kind of looked at this And we can say that no, they were not. Our concentrations at the highest were way below what they are today. This is the highest levels they've ever been. So this is again not today, but we can see that they are much higher than they were ever before. Based on this data, would you conclude that temperatures are warming up or cooling? Support your claim with the patterning you saw in the data. So again, just looking at the data and nothing else, the data seems to say that as carbon dioxide levels go up, temperature is going up. And so as CO2 and methane levels continue to rise, we would expect that the temperatures will continue to rise because the data is hinting at that. How could the trend in CO2 and methane levels and temperature affect the ecosystems along the coast of California? Okay, so this is, there's no picture or anything, this is just your thought, but if the levels keep going up, and there was a report just yesterday that the temperature in the Arctic is warmer than it's ever been, 62 degrees Fahrenheit, the warmest it's ever been on record. So as the temperatures of the globe go up, of course temperatures are going to go up everywhere. And so if the ice is melting, what is going to happen in California? What's going to happen to our local ecosystems in California along the coast? So we can talk about that just from what we've learned in our assignments, 1 through 5, which ecosystem change, and then 6 through 10, which is looking at changes in the atmosphere and how the changes in the atmosphere have caused changes over time. If you have any further questions, please see your science teacher, and have a nice day.